Good day, grade 12 learners. Welcome to today's Physical Sciences Chemistry revision lesson. My name is Tandwe Uwane. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center. As we all know that on Monday, the 13th of November, we'll be sitting for our chemistry paper, which is our paper 2 in physical sciences. So today we are going to look at each and every topic and try to identify those important facts about each and every topic in paper 2. Now, as you know that the structure of our paper, because we cannot shy away from this, you need to know what is it that we're expecting on Monday. We are expecting our section A and our section B. Our section A is our multiple choice questions, which is out of 20 marks, and there are 10 questions, meaning that each question carries 2 marks. Our section B is our structured or long questions, which is equal to 130 marks. And all in all, the chemistry paper is going to be our 150 marks and of the duration of 3 hours. Now, we know that we have 2 knowledge areas in chemistry, that is chemical change and matter and material. So chemical change is 92 marks and matter and material is 58 marks. And remember, matter and material, we are only referring to our organic molecules. So it means out of the whole 150 marks, 58 marks is from organic chemistry, and the rest, they form 92 marks, which will total to 150 marks. Now, as we know that when we look at our question paper, we are going to find our question 1, which is our multiple choice question. Our multiple choice question has all the questions. It means that you will find all questions being examinable in multiple choice question. Then we go to our question number 2. Our question number 2, we start with our organic molecules. Normally, we have our naming and our homologous series being assessed on that question. Question number 3 is our organic molecules again, where we are going to look at the physical properties of organic molecules. And question number 4 is going to be organic reactions. So you can see that from question number 2 to question number 4, we will be assessing or will be assessed on organic chemistry. Therefore, you need to pay a very serious attention when coming to this topic on organic molecule. Question number 5 will be the extent of the rate of reaction, and question number 6 will be chemical equilibrium. Then we go to question number 7, which is going to be our acids and bases. Question number 8, galvanic cells, and question number 9, electrolytic cells. So the reason why I'm giving you all the structure of the question paper, so that when you feel you want to start with any of the question, you just go straight to that question because you know where you are going to find it from the question paper. Now, these are the topics as I was explaining. All the topics that are outlined in paper 2 are provided on the slide, and we just explained or we just listed them on our previous slide. As we know that multiple choice is carrying 2 marks, so we always encourage you not to leave any question unanswered on the multiple choice, because definitely if you are leaving one question unanswered, it means you are losing 2 marks with immediate effect. So please don't skip any mark on multiple choice. If you don't feel comfortable in starting with multiple choice, it's still okay. You can start with other questions and end with multiple choice, but try by all means not to miss any question on multiple choice. Now let's go to our sections whereby we look at each and every topic. We know that when we look at organic chemistry, which we said is 58 marks, it started when we look at our functional groups. And remember, this table of functional groups is provided to you on your exam guideline, which is exam guideline 2021. I'm not going to repeat that because yesterday it was said that we are using exam guideline 2021 for all our examination. So all the homologous series and their functional groups are provided on this table, especially when you are given structures. I think when you are given structures, that's where you are going to use your functional group structure in order to see in which homologous series does a specific compound belong. And also, you know the names of different homologous series or different a series or group of compounds that are provided in organic chemistry. We are having different ways of identifying different homologous series. We can use the functional group, especially when we are provided the structure, or we can use our suffix when we are provided a name. And we know that our suffix will always assist us, especially when we are provided a name. Here is halo. So make sure that you have a way of identifying different homologous series. It's either by the functional group or by the suffix. And also remember that you can also be asked to maybe draw the structure of the functional group. So we expect that as you see the structures of the functional group that are given to you on this table, you draw them as they are, including the bonds under each and every structure, because we know that our carbon atom must always have 4 bonds around it. So if you are drawing a structure and you are indicating a structure of a functional group and you find that you are missing some of the bonds, definitely that structure will be incorrect. In chemistry, is either you know or you don't know. There are no other alternatives of providing marks except that you understand what you are talking about. Now, in organic chemistry, we know that we dealt with IUPAC naming, which was normally asked in our question number 2, but it doesn't mean that when you see it in question number 2, it won't be asked in any other question, maybe question 3 or question 4. So it means you need to know how to name each and every compound. And we know that when we name a compound, we must firstly identify where does it come from. Maybe we can say we use the functional group to identify where the compound is coming from. Or we can also use a suffix to identify where the compound is coming from. And that is the first thing that you're going to do as you're going to start giving a name of a compound or drawing a structure of a compound. Then the second thing, we know that we need to identify the longest chain. I think we have dealt with this one in several case instances whereby we said not all the structures that will be provided to us will be a straight chain. Therefore, we need to know how do we identify a longest chain using different forms of identifying a longest chain. So that is the second thing that you are going to do as you are naming your structure using the IUPAC naming system. And then you are also going to check whether there's a functional group. We know that if there's a functional group in a structure, definitely a carbon closer to the functional group will always take preference in terms of numbering. So you cannot number before you identify the longest chain. So the first thing, you're going to identify your longest chain, and the next thing, you're going to number your carbons, and you're going to look whether it is a functional group. If there's no functional group, you will look at the substituents. And already we know that our substituents, definitely they substitute normally hydrogens in our structure. They act like visitors. So you definitely need to check where do you find your substituents, and your numbering will definitely depend or will always start closer to the substituent. And then we know that we are using hyphens between a number and the alphabet. And definitely, if the hyphen is not part of the name and it was supposed to be included, that name already, it doesn't carry any mark because hyphens are part of the naming system. So we need to make sure that we know how do we put hyphens between the number and the alphabet. Alphabets are A, B, C, D, E. Numbers are 1, 2. So if you know that you have ended with an alphabet and then you want to start with a number, you definitely have to separate the two using a hyphen. We also use a comma between two numbers. If you say 2, 2, if there are 2 maybe methyls in the same carbon, or if there are 2 methyls or 3 methyls in a structure, we know that we are going to show the position and we are going to separate those substituents using a comma when they are numbers following each other. And we normally don't put a space between the alphabet, only in esters where we normally have a name and like a surname, because remember, an ester is formed from 2 different homologous series, which are alcohols and carboxylic acid. So we also sometimes indicate that this part is from an alcohol and then the other part is from a carboxylic acid. So I'm saying all the rules are provided to you on our exam guideline 2021, which is not going to be a problem when you start studying starting from today, because definitely I don't think we have a luxury of time to waste in terms of we're going to start maybe studying tomorrow. This won't be enough for you to be able to get that desired distinction that you want. Now let's look at different types of questions and try to remember what is it that we did under organic chemistry. Let's start with this one here. This question is based on the general formulas. The first thing that you need to know, they say which one of the following is a general formula. So as you know that when we started by giving you different homologous series general formula, because we said each and every homologous series is having the same general formula. So those are the compounds with the same general formula, because the definitions are very important, we know, and you need to always revise your definitions. So sometimes it might not be possible for us for this lesson to revise all the definitions, but you know that the definitions will always give you 2 marks for each and every question that you normally do. And it doesn't mean that you only need to do the definitions for you to pass a paper 2. You also need to know the concepts, and you also need to know what does each definition stand for. So we know that we are given the general formulas of alkanes, SCN, H2N plus 2, and we are given the general formula of alkenes, SCN, H2N. This one I'm just reminding you, and the general formula of alkynes, which was CnH2n minus 2. So the examiner here say which one of the following is the general formula of alkanes. Before you can even go and attempt the question, you need to remind yourself what is the general formula of the alkanes. And you can see here that this one definitely is for the alkenes, and then this one is for the alkynes, because you have reminded yourself. Definitely this one is the correct one, which represent what? Alkanes. And this one is for the alcohols. So from what we are provided here, our correct answer is number 3. So we are not going to waste many time explaining one thing, because we know what is it that is expected out of us in this topic. And there are lots of concepts that you need to remember. So that is why it is very important that you go back to your exam guideline, you go back to your notes, you go back to your classwork books and see what is it that you have done under organic molecules. Then they say consider the following statement regarding the compounds in the same homologous series. As I said, the compounds in the same homologous series, they will have the same functional group. They will also have the same general formula. So let's look at the options that the examiner has provided to us in order to see whether these statements correlate with what we know about homologous series. They have the same boiling point. Definitely this one, you know that when you look at the boiling point, there are many factors that affect the boiling point. So it doesn't mean that when you are in the same homologous series, you have the same boiling point, because sometimes your structure might be different in terms of the size. Sometimes your structure might be different in terms of the surface area. So those are the factors that affect the boiling point. And this one definitely will not be a classification of a homologous series. They have the same functional group. This one definitely it can be correct, because remember we agreed that as you are belonging to the same homologous series, it means you have the same general formula and also you have the same functional group. They have the same molecular formula. Definitely they don't have the same molecular formula because they are not the same. If they have the same molecular formula, it means all the compounds under the same homologous series must have the same formula, which is not correct. So what they have is the same general formula, not a molecular formula. Therefore, the only correct answer that we have for this statement is number A, which is our same, what is it, number B, number 2, which is option number A, which have the same functional group. Then when we look at this one, remember, we also talk about the names of the functional group. This question is based on the names of the functional group. So before you go to the options, also remind yourself, how do you know about what is it that you know about the names of the functional group? Number 1, they look for the functional group of alcohols. This one is not for alcohols, it's for carboxylic acids. And then this one, I think it is very important to know that if you are saying the answer is incorrect or the option is incorrect, you need to know where is it correct, because it's not that always the option will be always incorrect. It will only be incorrect for that specific question. So the correct answer for the functional or the name of the functional group of alcohols is hydroxyl group, which is our option D. And then here we are just saying which one is an aldehyde. This one is when we use a suffix, that's when we are going to check which one is an aldehyde. And I said suffix will always assist us in order to check what in which homologous series does a specific compound belong. And we know this one, it belongs to alcohols, this one is a ketone, and this one is an ester. So the only correct one is number A, which is our. So we are trying just to say what is it that you need to remember about different homologous series. Then this one is about the condensed and the uncondensed of a structure. Just be able to move from a condensed structure to a structural formula. So they're saying which compound is a carboxylic acid. For you to be able to do that, at least try and find and condense the structure so that you can see that this one is a carboxylic acid or is what. And you can see number A is a ketone, so it's not. So the only option if you are going to uncondense your structure, you'll find that is option number C, which is having COOH or carboxyl group as our carboxylic acid for this structure. Now we also looked at isomers. When we look at isomers, we know we have different types of isomers, but the question here is this: which one of the following compounds are functional isomers? Remember, for functional isomers, we only expect to have aldehydes with what? With ketones. And we also need to have esters with carboxylic acid. So if they are looking at the relationship and it's not part of the two pairs, then it means it cannot be a functional isomer. When you look at number one, methanol and methanol, they're definitely not functional isomers, and they're not even isomers, because when you can try to check their molecular formula, remember isomers are compounds with the same molecular formula but different structural formula. And we further say what is different about their structures. Sometimes it can be about the chain length, sometimes it can be about the position of the functional group, or sometimes it can be from different homologous series where they have different functional groups. So when you look at number B is butane and 2-methyl propane. If you can draw the structure of butane and 2-methyl propane, you will see that they have the same molecular formula. But these two, they belong to the same homologous series and they have the same functional group. So they cannot be functional isomers, but they can be referred to as chain isomers. The second one is propan-1-ol and propan-2-ol. Yes, the structures of propan-1-ol and propan-2-ol in terms of their molecular formula, they are going to be the same. They are also isomers, but they are also not positional isomers. They are not functional isomers. They are positional isomers. So the only correct one is where we find our carboxylic acid and our ester, because we have agreed that isomers which are functional isomers will belong to this. Now this one is about esterification. You will firstly identify that this structure is an ester, and the second thing you will say which alcohol does this ester belong to and which carboxylic acid does it belong to. How do we form an ester? We know that an ester is formed from a carboxylic acid reacting with a primary alcohol, because I need to be specific here, not any alcohol but primary alcohol. Let me just write the correct spelling of alcohol to give us an ester plus water. Now we know that for us to undergo this process, or for this process to be successful, there are conditions where we say we need a concentrated sulfuric acid as one of the conditions, and we must also heat the mixture for esterification to occur. So I'm just using this opportunity to explain esterification in totality, because I don't think that time will allow us to go back and look how esterification is done, or how we form an ester from an esterification process. So I always say when we have a structure like this, you will just take your oxygen as your boundary, which separates the alcohol side and the carboxylic acid side. And you can see that this one, because it doesn't have this CO bond, it means it is coming from the alcohol. And this one, after the oxygen is coming from the carboxylic acid. So we just count the number of carbons of the alcohol and the number of carbons of the carboxylic acid, so that we can find the name of an alcohol and the carboxylic acid that make this ester. So it's going to be 1, 2, 3, which means we said it's a primary alcohol, so we know it's propane, 1 all, and then we have 1, 2, which is our carboxylic acid, so it means it's going to be ethanoic acid. Remember, the word acid is always part of the name. So when you look at our options, they're saying which reactants can be used to prepare this compound. We are expecting to have a propane 1 all and the ethanoic acid. And if you look at all our options, the only correct answer is number C, where we find our ethanoic acid and our propane 1 all. Remember, the structure can also sometimes be written from the side of the carboxylic acid to the side of an alcohol. It must not be like it is now a different structure. You just switch the structure to the other direction for you. Then in terms of the empirical formula, because normally that's where we are asked the empirical formula when we are doing our organic molecules. They are saying which one is the structure of empirical formula of 1,2 dichloroethane. You cannot find the structure of the empirical formula if you don't know the molecular formula. So it means we need to start by knowing the molecular formula of 1,2 dichloroethane for us to come up with a molecular formula, and then we find there. So it's an ethane, and in each ethane there is a chlorine, and then we complete our structure by putting the hydrogen. So it means the molecular formula is C2, and then 1, 2, 3, 4, H4, and then Cl2. So how do we find an empirical formula? We just divide with the smallest divisible. We can see that here is 1 is 2, 2 into 2 once, 2 into 4 twice, 2 into, so it means we have CH2Cl. So this is going to be our empirical formula for 1,2 dichloroethane. This one definitely is incorrect. Let's look at number B. Number B, yes, is correct. Number C is incorrect. And this one, the reason why they give you D is because this is a molecular formula, is not the empirical formula. Just to be a distractor, whether you understand what you mean by empirical formula or the difference between empirical formula and molecular formula. Here we are now looking at the IUPAC naming system. As I said, you need to go back and check how do we name different homologous series. Sometimes the naming is based on the functional group, because you're going to start by numbering from the functional group. Sometimes it's about the most substituted carbon, or sometimes it's about the most substituted side. Remember, all those examples that we did in terms of naming, they must now be like, we must now go back and check each and every structure that we talk about, and check why are you numbering your compound the way you are numbering it. So all those things that I'm just mentioning about, whether it's about the closest substituent or the functional group, they need to be remembered. So you can see that this structure, the examiner decided to give us a vertical structure, but when you look at the functional group, you can still see that this is just a carboxylic acid. And what is nice about carboxylic acid is that their functional group actually is always their first carbon. So you need to identify the longest chain first. It looks as a very small structure, but sometimes if you are not careful, it can be a very complicated structure the way it is drawn. So if this is we are going to identify our longest chain, because we know that this is a carboxylic acid. So we're going to start and say maybe 1, 2, 3, 4, or we can say 1, 2, 3, 4. Definitely it cannot be 1, 2, 3, because it's not a straight chain carboxylic acid. So when I identify my chain as this one, it means I'm having a methyl here, another methyl, another methyl. So I'm having 3 methyls on my structure. But now I know that always my carbon number 1 will be this one. So it means in carbon number 2, I have 2,2 methyls, and then also in carbon number 3, because if this one is 4, it means this is my methyl, or if this one is 4, this one is my methyl. So in carbon number 3, I have also another methyl. So when we write numbers, we said we use a comma. So it's 2,2, 3, then dash. Because there are 3, we use the word trimethyl. Then if these methyls were not here, it means this was going to be what? A butanoic acid. Please don't forget the word acid. So it's 2,3 trimethyl butanoic acid. And then it's then that you can go and check your options. So you can see that number 1 is 2,3 trimethyl butanoic acid, which is what we got. 2,3 definitely is incorrect. So the only option, but it is nice when you do it first before you go to the options, because sometimes the options can be confusing. Then let's look at one of the longest question under our question 2 and see how can the examiner ask questions on question number 2, which is what we're doing all along. The letters A to D in the table below represent 4 organic compounds that belong to different homologous series. So already you know that you will not expect all of them to have the same functional group. We are having 2-methyl propanol. Definitely the first thing that you need to do when you are given a table with compounds, just know where does it come from. And by knowing that, it assists you to know when they are asking a question to just go direct to what you have discovered from your table in order to answer. And you can also maybe draw a structure of this 2-methyl propanol just for you to be on the safer side. You see, so in carbon number 2 we have a methyl, and this is a propanol and it's an aldehyde. So those are the things that you need to do before you start answering questions. So we are not going to do for every structure, but I'm just showing you how can you firstly interpret your table before you start answering questions. And then obvious number B, there is no way that we cannot name it. This is a carboxylic acid, so our carbon number 1 is 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. So 1, 2, so the longest chain is 5. So it means our name, we can also use a straight chain as our longest chain. And you can see here we have an ethyl, and here we have a methyl. So immediately when you identify it like this, you already preparing yourself to know the name. And then this one, because it's having a triple bond, it means it's an alkyne. And we know this one is a hydrocarbon, because hydrocarbons are alkanes, alkenes, and alkynes, compounds of carbon and hydrogen. Also, this one is our hydrocarbon, but remember this one is an alkane. So the difference is that, what is different about the two structures or the two hydrocarbons is that this one is saturated because it's a compound with single bond only. This one is unsaturated because it is having multiple bonds. So you can then go to your question, define a homologous series. As I said, that there is no way that we can go to the exam on Monday without knowing definition. So a homologous series are compound with the same general formula at which each member differ from the next by CH2. So immediately when you have said they have the same general formula, you have already given yourself 2 marks for the definition of the homologous series. Go back, look at those definitions. I know sometimes they become too many for you to remember, but at least know the keys or the facts about each and every definition, because obviously there will be those underlying words about the definition that the examiner will look at. And then write down the letters that represent saturated hydrocarbon. Already I've done it as I was trying to interpret my structure, or as I was trying to interpret my table, because I was trying to make my work or my job easy as I'm going to the questions, to say I know what is happening with the structures. So as I'm going down, I will be just going back to the table and check whether does that question correlate with what I've discovered on the table. So we know that this one is number D, which is our pentane. And then the general formula of the homologous series of C, yes, C, we discovered it as an alkyne. So we definitely expect the general formula to be CnH2n minus 2, which was the first question that we did this this afternoon, as we were trying to remember about different homologous series and their general formula. And then the structural formula of A, yes, remember we have drawn the structural formula of A because a name was provided. So a structural formula of A, which is going to be our 2-methyl propanol, is going to be exactly as the one that you draw here at the top. Make sure that always you check the number of bonds, especially when you are drawing structures. Make sure that you check the number of bonds, that there are always 4 around each carbon. Remember, we are having 9 questions, which is almost about 9 topics. So sometimes it might be like we are very fast as we are explaining this. But remember, we have a link. You are going to go back as you are going to revise. You can go back to the link. Where you don't understand, you can pause the link and try to understand what is it that we are referring to as we're explaining this, because when you are in this live lesson currently, maybe there will be some of the facts that you miss about a certain topic, so it won't be enough for you to understand now as we are rushing because of the time factor. Compound D has 3 structural isomers. So when they say it has 3 structural isomers, it means it is that compound plus 2 other structures that you can draw that will have the same molecular formula as that. And we know that our compound D was our pentane, just to remind you. So our pentane is having 3 structural isomers. So the first one is going to be pentane itself. And then they want us to draw the structural formula, write down the structural formula of the isomer of the shortest chain. So if pentane is 5, it means we'll move from 5 and go to 4, and from 4 a longest chain and go to 3. We can't go further than 3 because definitely it won't suffice. So it means it's going to be 1, 2, 3, 4, 5, which is our pentane, which is our saturated hydrocarbon. Then the next structure that we're going to draw, we are trying to reduce the chain of pentane. We are going to draw 1, 2, 3, 4. But you know that now we must introduce a branch to reduce the surface area. So we are now reducing the surface area. We are drawing now a methyl butane. Sometimes we can say 2-methyl butane, but there's no way, there's no any other position where you can put the methyl except in carbon number 2. And the last one, which I think is going to be our correct answer, is going to be 1, 2, 3, which is a propane. But now we are going to introduce 2 branches in carbon number 2 so that we make our chain as short as possible. So our shortest chain, it means it's going to be this last structure, which is going to be 2,2 dash dimethyl what? Propane. So this is the shortest isomer or chain isomer of our pentane. So when the examiner say draw an isomer, especially when they talk about the chain isomer, try to reduce the number of a carbon chain and see whether you can be able to draw the same structure when you are reducing those carbon chain. And then a balance equation for the combustion of, so a combustion reaction is when alkanes react with excess oxygen to give you what? Carbon dioxide and water. And we also dealt with the issue of how do we balance those reactions. So go back and look at the previous videos where I was assisting you how do we balance those equations. But now we are going to look at remember, we're going to use our general formula just to find the molecular formula of pentane, which is going to be C5H12 plus O2, and it will give us carbon dioxide plus water. Then we're going to put 5 here, and we're going to put 6 here. 5 times 2 is 10. 10 plus 6 is 16. 16 divided by 2, we're gonna put our 8 here just to balance our oxygen. So this is how do we mark this? Is 1 mark for the reactants, 1 mark for the formula, and the 1 mark for the balancing. So you must make sure that you just go back and revise how do we balance these equations. Then we also looked at physical properties. Remember, the physical properties that we are referring to for our syllabus is the boiling point, the melting point, and the vapor pressure. The first thing that you need to remember, you need to remember each and every definition. Boiling point, whereby the vapor pressure is equal to the atmospheric pressure. Melting point is when the solid and the liquid phase of a substance are at equilibrium, and the vapor pressure is the pressure exerted by vapor at equilibrium with its liquid in a closed system. So definitely go back and remind yourself about those definitions before you can start interacting with the questions on physical properties. Now we are also saying, because these are the physical properties that we are going to measure, so they will become our dependent variables. So our boiling point is our dependent variable, melting point dependent variable, and vapor pressure, they are all our dependent variable. What are they depending on, or what is it when you change it affects the boiling point or the melting point of the vapor pressure? They are affected by these three independent variables. They are affected by the chain length, or the type of the functional group or intermolecular force, or the surface area. As you can see that when I was drawing the structure of pentane, I was reducing the surface area from pentane to methyl butane, from methyl butane to 2,2 dimethyl propane. And you can see that as the surface area is being reduced, obviously the boiling point or the melting point or the vapor pressure of that compound will be affected. So that is why I'm saying those are our independent variable. Independent variable is the chain length. So what is happening with the chain length, or what is the relationship with those independent variables and the dependent variables? We understand that the longer the chain, then we need to say what will happen to the strength of the intermolecular forces. Therefore, there will be stronger intermolecular forces. And if the intermolecular forces are stronger, then it means there will be more energy required to overcome those intermolecular forces. So what will the examiner expect from us? As the examiner will say to us, maybe for 3 marks, explain why maybe the boiling point of compound A is different to the boiling point of compound B. The first thing that you look at, you look what makes the compound A to be different from compound B. Then if it is about the chain length, then you will start by saying maybe compound A has a longer chain length as compared to compound B. Therefore, compound A will have the stronger intermolecular forces as compared to a compound B. Therefore, more energy will be required to overcome the intermolecular forces of compound A than B. That is when you are referring to the chain length. But when you look at the type of intermolecular forces, then you need to go back and check different types of intermolecular forces that are found in different compounds of different homologous series. We know that all the compounds, or all the families, let me just refer to them as families, they have London forces. London forces are the weaker intermolecular forces that we find. Sometimes we normally refer to them as the induced dipole forces. So it's also correct to say induced dipole forces as comparing to, or as indicating to, the London forces. But now, when you look at the dipole, which is the second group, dipole will only affect aldehyde, ketones, esters, and haloalkanes. And what you must understand is that dipole are now stronger than London forces. So the group where we have our aldehydes, our ketones, and our esters, they do have London forces, but on top of London forces, they will also have what? Dipole. And the last one is the one that are having at least stronger intermolecular forces, which are referred to as hydrogen bonds. Now, also, when coming to alcohols and carboxylic acids, we know that alcohols have one side of hydrogen bond, whereas carboxylic acids have 2 sides of hydrogen bond. So even the strength of the one side and the 2 sides of hydrogen bonds differs. So the group that is having the strongest intermolecular forces as compared to all these forces are the carboxylic acids. But remember, these are van der Waals forces. They are all weak forces. But we know that van der Waals forces. But you know that even within the weak, we might find the strong forces. So it doesn't mean that now, because we are referring to the 2 sides of hydrogen bond as the strongest, we mean now these are the strong bonds, or these are the strong forces. No, they are still weak, but they are stronger than the dipole, and they are also stronger than the London forces. So when you compare, you just need to identify the forces that are going to be found in each and every homologous series, so that you can be able to compare. The last one, I think, is the one that I just referred to as the surface area. We have seen the pentane going to methyl butane going to 2,2 dimethyl propane. So you can see that the more you reduce the surface area, the more you reduce also the strength of the intermolecular forces, because we said the larger the surface area, the stronger the intermolecular forces. However, the smaller the surface area, the weaker the intermolecular forces. So just go back and remember, how do we compare different types of intermolecular forces? Using number one, you are going to look at the difference about the structure. Is it the chain size? Is it the strength? Is it the type of intermolecular force, or is it the surface area? And the last thing that you need to mention that what will happen to the energy that is needed to overcome those forces. And I think it is advisable that you use bullet form as you are going to explain, because you will just know that the first bullet we're dealing with the independent variable, which is the different about the structure. The second bullet, it will be about the strength of the intermolecular force, and the third bullet, it will be about the energy needed to overcome those intermolecular forces. So here we can just have one multiple choice question where it says, which one of the following has the lowest boiling point? I think by now we know that we look at the strength of the intermolecular forces in terms of the chain length, in terms of the type of intermolecular force, or in terms of the surface area. So when you say the lowest boiling point, it means when you look at these compounds, this one is having lambda, I agree. This one is having dipole, and this one is having hydrogen bond, which can be one side of hydrogen bond, and this one also is having lambda because it's an alkane. So you can see that now you cannot compare between the dipole and the hydrogen, because both of them are stronger than lambda. So it means we are comparing between D and A, whereby A is our butane and D is our methyl propane, even though they belong to the same homologous series, but their surface area is also different. So you look at between butane and which one? This one is having the smaller surface area, and butane is having the larger surface area. So the smaller the surface area, the lower the boiling point, because the smaller the surface area, the weaker the intermolecular forces. This one, even though I'm not going to talk about it, is about the chain length. So here you compare the chain length of these different compounds, and you check which one is having a highest boiling point. And we know that the longer the chain length, the stronger the intermolecular forces. So definitely, as you are going to interact with this, you will find your answer being number D. This one is about the strength of the intermolecular forces. We know now we are given names of different compounds. They say you must look at the strength in the increasing of the intermolecular forces. So as you know that this one is dipole, so you'll identify them like this: lambda, and then this one is one side of hydrogen bond, and then this one is two hydrogen bond. So you will just look at each and every and see which one is the correct one. And I think number C is going to be the correct one, because it will start from lambda, and no, I think it's number D. This one is incorrect. Lambda, dipole, one side of hydrogen bond and two sides of hydrogen bond. So our correct answer, as you're going to look at this question and you're going to interact it, it's going to be number D, because we know that the strength increased from lambda too. And then we are also going to be expected to answer questions on graphs. In any of the questions in physical science, you know that graphs will always be part of us. So here you are given the relationship between boiling points and the number of carbon chains. And already you know that the longer the chain, the higher the boiling point. So you expect that as the number of carbon chains increases, the boiling point must also increases. Therefore, we are given the primary the straight chain of aldehydes, alkanes, and primary alcohols. And also you also know what is the difference between the strength of the intermolecular forces of the compounds or the homologous series that you are provided. So they say which compounds are represented by the curve B. So we know that we have aldehydes, we have alkanes, we have primary alcohols. Alcohols will always have a higher boiling point. So this one will represent alcohols, and then it will be followed by what? By the aldehydes, because they have dipole. And the last one, it will be our London forces, which is our alkane. So B is not representing alkanes, alcohols. It's only representing what? C. Carboxylic acids are not even represented here because they are not even part of the comparison in terms of the compounds that we are provided. So B is the correct one. And the reason is because aldehydes will have dipole, which are stronger than London forces, but weaker than hydrogen bonds. So they are in between London and hydrogen bonds. Then also here is a long question where you need to define boiling point. We've defined the boiling point already, and you need to get 2 marks for that. And then explain why the boiling point of alcohol increases as the number of carbon atoms increases by referring to the type and the strength. So the examiner sometimes will tell you what is it that you must talk about as we are explaining. So we know that alcohols have what? Alcohols have hydrogen bonds. So alcohols will write alcohols have hydrogen bonds, and the strength of the intermolecular forces. So number 2, we know that the longer the chain, the stronger the intermolecular forces. You can see I can't even write IMF because I must write it in full. Intermolecular forces, and then the higher the boiling point. So we need to see whether you understand what are you talking about. So the type of the forces are a hydrogen bond, but the relationship is that the longer the chain, the stronger the intermolecular forces. So everyone must know what is the relationship in terms of the boiling point, the melting point, and the vapor pressure. And we know that if the boiling point is higher, we expect the vapor pressure to be lower. So the relationship that goes proportional is the melting point and the boiling point. Both of them, if the one is higher, the other one is also high. But vapor pressure is the opposite of the two. Explain why the curve of alcohols is higher than that one of the ketones. It was about the ketones and the alcohol. So we know that, and type, you also refer to the type and the strength. This is the one now that I was talking about, because we are given 3 marks. First of all, you need to talk about your independent variable. So you need to say that ketones or alcohols have what? Alcohols have hydrogen bonds. And ketones have what? And ketones have dipole. So this is the first statement that you're going to write because we want to see whether you know the type of intermolecular forces that each has. And then number 2, you're going to talk about the strength now. So you know that hydrogen bonds, not ketones or alcohol, hydrogen bonds are stronger than dipole, which is the second mark. And the third mark is about energy. More energy is required to do what? To overcome the intermolecular forces of hydrogen bonds than what is it? Than dipole. So you will see this is the questions you will also, because they will be there on your link as you're going to look at them. You will also be able to complete all the questions on this. But the main thing that I wanted to explain is about how do you answer the questions when they say explain the difference between the boiling point and which bullets are important for you to mention. And also this one is about the chain length. You can look at the chain length, but what is more interesting is that when they say here, the last one, they say how will the vapor pressure of 2-methyl propane compared to the vapor pressure of compound D? And you can see that compound D is our butane. 1, 2, 3, 4. So you can also refer right higher than or lower than or equals to. So those are the questions that you can expect. But when they ask you about the comparison between alcohols and carboxylic acids, definitely mention the issue of the sides of the bond, 1 side of hydrogen bond and 2 sides of the hydrogen bond, so that you can be able to compare the two. Also, okay, this one I think is this year's June paper. Just go through it. It's June 2023, where they gave you a graph. It's almost the same as what we were doing now in terms of the alcohols and the ketones. You can see here they've given you compounds and the same molecular formula. So normally the examiner will ask you, why are we giving the same, or why are we using the compounds of the same carbon chain? Is definitely because we want to make sure that there is a fair test as you are doing your experiment. So you will also use the same concept to identify which one represents, because here it was about the alcohols, and I think there were also carboxylic acids. As you're gonna look at this question, you will say, oh yeah, they are ketones, alcohols, carboxylic acids, and another alcohol that is branched. So when you look at it, they will want you just to say, you just look at the graph, and they say which physical property is represented by X. Remember, at the X there's a temperature, and this temperature we know is our boiling point. And then because you are also told that we are investigating the temperature whereby these compounds are, so we are looking at the boiling points of different, because we can see that this one is our compound P, or compounds P, they are having a highest boiling point, and then followed by the rest. So just go through this question and check what is it, but it's the same concept as the other one. Okay, the organic reactions, as we know here, I think I will deal with this slide more than any other slide that is here. This one is about the addition reactions, and all the addition reactions that are here, they are also provided conditions. So I know that most of you were always saying you are having a challenge of understanding reaction conditions. All reactions conditions are here. As you can look at the first one, remember these are the reactions of alkenes. So here alkenes will react with either a hydrogen or water or halogens or hydrogen halides to undergo a reaction and form a saturated compound. So what we are expecting is that when an alkene undergo addition reaction, the double bond of an alkene will be broken. And we know that if it is a double bond, it means it is unsaturated. So immediately when the double bond is broken, it means that unsaturated compound will become saturated. And we need to also have an expectation of what is the product that will be formed when we add anything or a certain substance in an alkene. So we can see here we are adding Cl2, and when we are adding Cl2 we are adding halogens. So already we know that the name of the reaction will be halogenation. And what is needed as conditions, we need unreactive solvents for halogenation, and we also need an alkene that will act with any halogen. It can be chlorine, it can be bromine, and the product that will be formed is a haloalkane. So these are the reaction conditions, and these are the expected products for every addition reaction that you're gonna see on Monday. And then this one is about hydrogen halide, HBr, reacting with an alkene. Remember, that is when now when you are adding substances or different substances in a compound, you need to know where is hydrogen gonna go and where is the other substance gonna go, especially the two reactions, which is hydrohalogenation and hydration. Hydration is the reaction between an alkene and water. Hydrohalogenation is the reaction between an alkene and hydrogen halide. So we are using Markovnikov rule. We know that we will normally get our secondary alcohols or our secondary haloalkanes as we are gonna deal with this type of reactions. And remember the definitions of primary, secondary, and tertiary alcohols, and tertiary, and also primary, secondary, and tertiary haloalkanes, which are part also of the definitions that we listed for you. So we are also going to get we are going to undergo hydrohalogenation. The condition is that no water must be there, and we also need unreactive solvent. And we are going to get our haloalkane again when we do hydrohalogenation. And we know that now the difference between the two haloalkanes is that this one will have 2 halogens, and this one of hydrohalogenation will have 1 halogen, because we are just adding only 1 halogen. And then this one is hydrogenation, where we add hydrogen. We need a catalyst like platinum or palladium or nickel, and then we are expecting to find an alkane when we add this one. And the last one is hydration. We need a small amount of sulfuric acid as one of the reactant here during hydration, and also we need excess water for us to get an alcohol. And normally if we have more than 3 carbon chains, we are going to get our primary, this one is incorrect, we are going to get our secondary alcohol, as we are going to use our Markovnikov rule. And then this one is a substitution reaction of alkanes. What you must know is that substitution reaction is only undergone by either alkanes, alcohols, and haloalkanes, because they are all saturated, and they can be, we don't have any double bond to break, but we can only replace, we can only substitute. So this one is a halogenation, but now remember, this is a halogenation of an alkane. We just do a substitution reaction and we get our inorganic compound that will be formed as we do this substitution reaction. And for this substitution reaction, or most of our substitution reactions, we need sunlight, and also we are going to find our haloalkane and our salt. And also for alkanes, I've already explained the combustion of alkanes. And in terms of elimination, one of the elimination reaction that alkanes undergo is cracking, whereby a large molecule is broken down into smaller useful molecules that will form either an alkane and another alkene. We are going to take a 1-minute short break, and when we come back, we're just going to look at the reactions, or one example of the reactions, then we go to other 4 topics. Thank you. Welcome back, grade 12s. I know it's just a water sipping a break, because definitely we don't have time. We will try and cover as many topics on chemistry as possible. So that is why we decided to just make our 1-minute break so that we can continue with our session. Now, the first question here is based on hydrolysis. Remember, this is a reaction of a salt and water. And our salt and water, and our hydrolysis is a substitution reaction. Remember, this is an example of a substitution reaction whereby haloalkanes, in the presence of diluted strong base like sodium hydroxide, give us an alcohol and a salt. So when they say here, which one of the following product formed during hydrolysis of bromoethane? Already bromoethane is having 2 carbon chains, so we expect during hydrolysis to form an alcohol. So the question actually it says, how will the bromoethane be changed to an alcohol in the process of hydrolysis? So we expect it cannot be water, it cannot be ethane, because ethane, it must be elimination. Remember, all the alkenes will be formed during elimination reaction, and then bromine, it won't be formed at all. during the process of hydrolysis. So the only correct answer for the hydrolysis of bromoethene is alcohol. How does it happen? It means the bromoethene, you can put bromine in any carbon because there are only two, will react with dilute sodium hydroxide, because I know it's a strong base, and when we are going to dilute it, and then what is going to happen is that where there is Br, we're just going to replace with OH, because the reason why we are using that dilute strong base, we want the hydroxyl group of the alcohols. So we are going to have our alcohol, which is ethanol. We can put OH where there was Br, and then after that, remember, our Br was not used, was replaced by OH. So it means it must now react with sodium so that it forms sodium bromide, which is our inorganic product. So this is the process known as hydrolysis. And what are the other conditions for our hydrolysis? We also need mild heat, or we can say we want UV light, which is our sunlight, UV light for the hydrolysis. So these are the two reaction conditions. So sometimes the examiner will give you the reaction conditions for you to be able to know what type of reaction is occurring. This one, which one of the following compounds will decolorize the bromine water? This is the reaction we use for tests for saturation. When we want to know between which compound is unsaturated and which one is saturated, we use our bromine water, which is brown in color, and make it to react with those compounds. Normally we say in a dark room, because we know that light also affects our substitution reactions. So we'll just place the compounds in a dark cupboard, and we pour drops of bromine water between the compounds. And we know that immediately when the color of the bromine water changes from brown to colorless, we are having what? An unsaturated. So an unsaturated compound is having that capability of decolorizing bromine water with immediate effect. So obviously, if they say here, which one of the following compounds will decolorize the bromine water fastest under normal conditions, we will expect any unsaturated. And this one, remember, is saturated. Even this one is saturated. This one is not even part of our list of saturation and unsaturation. So the correct answer is going to be our alkene, because alkenes and alkynes, they are the ones that we normally use as our unsaturated hydrocarbons to test for a saturation using brown bromine water. Here we are saying this one is also our substitution reaction, and is our hydrolysis reaction. So there's no need for us to look at it. And then this one, we are using concentrated sulfuric acid, and we are going to find this compound. And if you can draw the structure of this compound, you will see that this is an alkene. And I said whenever an alkene is formed, it shows that elimination reaction took place, because an alkene will only be a product of elimination reaction of all the four saturated compounds. And then you find that plus water. So what do you need to remove this water from an alkene? You will definitely need sulfuric acid. So what is this? This is going to be our alcohol, but they are saying which one of the following compounds is reactant X. Now we are going to get this alkene, and when we get this alkene, they are saying is the tertiary, primary, secondary, or this one is definitely incorrect. So because our alkene is a straight chain, it will not be a tertiary. What is it? It will not be a tertiary alcohol. It's either is primary or secondary. So if you look at primary alcohol, which is gonna be 1, 2, 3, 4 propanol, the OH is gonna be here, and then we do the elimination and see whether the removal of water will form a primary or secondary alcohol. Then the next thing is that we are going to remove this OH, because remember our structure doesn't have OH, and this one, and it means the double bond must be introduced in carbon number 1, which is definitely not gonna be the correct one. So it means here, because remember the double bond is in carbon number 2, it means we are going to use a secondary alcohol whereby OH is in carbon number 2, or OH is bonded to a carbon, which is bonded to two other carbons, and then it means now we'll remove OH and one of the carbon. That's when we are going to find our but2-ene, because this one is but-2-ene. So it means it is formed from the secondary alcohol. So we need to know how do we eliminate. We eliminate from number one, we will eliminate what is not needed as the product, and number two, we will check the weakest, like the carbon number 2 here is the one that is having fewer hydrogens as compared to these two. So we always target the one that is having fewer hydrogens for us to eliminate from it. Then, okay, this one, okay, let me just go back a little bit. This one is about cracking. We explain cracking. We know cracking is when we reduce a big compound, we break it into small useful compounds. So the only thing you must make sure that whatever that is going to be product of cracking will add up to 15 carbons and 32. So this one at least is all about balancing of equations. And then here, this question, the reason why I chose it is because, let me just go to the next, is because when you look at the compounds that are provided, you are provided a haloalkane here. And because we are used to straight chain haloalkanes, you will find that sometimes you will think that it will always be a straight chain haloalkane that will undergo hydrolysis, or it will always be a straight chain alcohol that will undergo substitution. So we need to be very careful on that. We are having our haloalkane, which is compound P, and it is undergoing reaction 1, and there's a dilute sodium hydroxide. So already they are telling us that this is a substitution reaction because of the conditions, and it's going to give us 2-methyl butane 1-ol. So our alcohol that is formed from this haloalkane is not a straight chain. And if our alcohol is not a straight chain, it means we are not going to have a haloalkane that is a straight chain. So whenever you are formed from a straight chain, you will become a straight chain. But if you are formed as a branch, it means our haloalkane is also a branch, is not a straight chain. And if this is 2-methyl butane 1-ol, it means where there is ol, we are going to put our bromine, and we are going to leave our methyl where it was, and then we are going to find the name of our haloalkane as 1-bromo-2-methyl, and then it's going to be a butane, because they have. So make sure that whenever you are provided with a structure and is forming a product, check whether it's a straight chain or not. Also here, the conditions are concentrated sodium hydroxide. So already we know that this is elimination reaction because of the conditions. And then during elimination reaction, we expect an alkene to be formed. An alkene also that will be formed here, not alkane. Alkene will also be a branched alkene. And here a branched alkene will undergo addition reaction and form product Q. Because of HBr, it means product Q will be a haloalkane. Just go through it and see how are these different reactions going to be formed. And already we have talked about different reaction conditions. So this is the question. Compound P can be used to prepare R and Q as shown in the flow diagram. So compound P is an alcohol, and it reacts in the presence of a hydrochloric acid to give you a haloalkane. So obviously, because this one is saturated, and it also produces a saturated compound, from our triple S to USA strategy, you can know that from saturated to saturated is substitution, from saturated to unsaturated is elimination, and from unsaturated to saturated is addition. So you can also apply that strategy here in order to find the type of reaction that will occur in reaction number 2. And also in reaction 1, we are having concentrated sulfuric acid, and you can see that what is formed here is an ester. So obviously it means this alcohol will react with what? With a carboxylic acid for reaction 1. This is just an esterification reaction to form this ester here. And if you uncondense the structure, you can also be able to find what is the name of the ester. And then they say beside the catalyst, which is our sulfuric acid, write down another reaction condition for reaction 1. We know that we agree to say another reaction for esterification is what? Is heat. And then the structural formula of our alcohol. From an ester, we can just find out that is 1, 2, 3. So obviously, we are using primary alcohol. So this is going to be propane -1-all. And IUPAC name of R, we can find what is the IUPAC name of, IUPAC name of R. And also, we can also find the functional isomer of R. So our R, remember, is our propyl ethanoate, our alcohol, our ester ethanoate, and its functional isomer. Now it means we must just draw a carboxylic acid from this ester, which is 1, 2, 3, 4, 5. We just count the number of carbons of an ester for you to move to a carboxylic acid. So you are going to draw a structure of pentanoic acid. So these are just few reactions that I just said we need to talk about and try and see whether we can be able to answer this. Here we are talking about, these are the new type of reactions that the examiner will normally ask in terms of the two-step processes or three-step processes, to say how do you move from one type of a compound to another by undergoing different types of reactions. Like this one, it's a primary alcohol that contains 3 carbon atoms is converted into secondary alcohol. We know that for us to convert an alcohol from primary to secondary, it means an alkene must undergo addition reaction, where we are going to use Markovnikov rule in order to find a secondary alcohol. So step 1, we must find an alkene, and the only way to find an alkene is through elimination. And that alkene will undergo addition reaction, and we are going to find a secondary alcohol through what? Through Markovnikov rule. So the two-step process is, just ask yourself, how do I move from one process to another by undergoing different reactions? And definitely, if you want secondary structure, you definitely need to undergo a certain addition reaction so that you can use Markovnikov rule to find the secondary reaction. So you will look also at these different questions and see whether you can also be able to answer. But here I was just trying to give you a clue on how to move from step number 1 to step number 2. Okay, I will not look at this. We will go straight to our rates of reactions. Our rates of reactions, remember, the first thing we need to list the factors that affect the rate of reaction. We know them by now, but more than that, we need to use collision theory to explain how does each factor affect the rate of reaction. So we know the conditions for the effective reaction. We need minimum energy that is equals to or higher than activation energy, and we also need correct orientation. And definitely those are the 2 conditions for the effective collision. But now what is going to happen is that we need to know how does the change in each factor affect the rate of reaction, and the only change that we need is the factor that increase the rate of reaction. So we'll start by looking at the increase in temperature. So how does the increase in temperature affect the rate of reaction? The increase in temperature do what? It increases the average kinetic energy of particles, and as the average kinetic energy of particles will increase, there will be more particles with sufficient energy that is greater than or equals to activation energy, and for that then there will be more effective collision per unit time. Remember, per unit time, it means per second. So it means as you increase temperature, there will be more effective collision per unit time, and the reaction rate will increase. So the examiner will ask, what will happen if you increase the temperature? Use the collision theory, and the bullets that I just mentioned are the bullets that we expect to see as we are explaining how will the temperature increase the rate of reaction. And we are also using the Maxwell-Boltzmann distribution curve to show how will the increase in temperature affect the rate of reaction. So here you need to know how will the shape of the graph change and what is going to happen after. So this one is graph T before the temperature is increased. This one is graph T2 after you've increased the temperature. So the graph will slide to the right and will be on will cross to the first one, and it will be higher than the first one. So this is the first graph that will indicate the increase in temperature according to the Maxwell distribution curve. And then this one is the catalyst. Remember, what does the catalyst do? The catalyst will provide an alternative pathway of lower activation energy, and after that there will be more particles with sufficient energy that is equals to or greater than activation energy, and there will be more effective collision per unit time, and the rate of reaction will increase. So what does the catalyst do? It just reduces the activation energy. It just lower the activation energy of the reaction without itself undergoing any permanent change. And the one, okay, also here you can see the activation energy being reduced from here to here by the addition. Remember, we don't increase the catalyst, we add a catalyst in a reaction, but we can increase the temperature and we can also increase the concentration. Now when you increase the concentration, this one indicates a lower concentration, and the one at the top will indicate a higher concentration. So what do you do when you increase the concentration? You are increasing the number of solute particles per unit volume. You are creating a correct orientation. So the increase in concentration will increase or will result in the increase of the number of particles per unit volume. Therefore, the second bullet and the third bullet will always remain the same. So as you have understood the first bullet of temperature and the second bullet of temperature, it is the same as the first and the second bullet of concentration. So these are the shapes that we are expecting from the Maxwell-Boltzmann curve distribution to be understood, to say this is the graph that represents concentration, this is the graph that represents temperature, and this is the graph that represents a catalyst. Here we are given the reaction rate expression. They're saying, remember, reaction rate we can express it by the change in concentration of the product per unit time. So, or the change in concentration of the number of moles, or the change in concentration of the volume per unit time. So here they're saying we can express the reaction rate by grams per mole. This one we know is about molar mass. Energy consumed per mole, definitely incorrect. Also, volume of a gas form per unit time, yes. Moles product of the product per unit liter, this one is incorrect because we can only express it in any change per unit of time. Can I just go straight to this long question here? Under the rate of reaction, here we are given a reaction between sodium thiosulfate and excess hydrochloric acid. Immediately when the examiner says excess hydrochloric acid, the examiner is saying now sodium thiosulfate is our limiting reactant. So it means when we are dealing with a calculation, that is the reaction that we are going to use for the mole ratio. And then we are given the balance equation of the sodium thiosulfate and hydrochloric acid to form salt, sulfur, sulfur dioxide, and water. So we are using this flask to check the disappearance of this mark here as the sodium thiosulfate is formed and forming a precipitate during this reaction. Now, what is going to be given to you is a table like this one. So when you are provided with a table, the first thing that you look at what is the same about the table, or you can identify your dependent and your independent variable of different reactions. Normally, we compare two reactions. So you can look at reaction 1 and reaction 2, or reaction 2 and reaction 3, or reaction 3 and reaction 1. That is how we normally compare our reactions. They say define reaction rate as I explained it. the change in the concentration of the reactants or products per unit time, and write down the name of the independent variable or for comparison of experiment 1 and 2, as I was saying that we're gonna look at the two different experiments to compare. So 1 and 2, what is not the same is the concentration of hydrochloric acid. Otherwise, all the other variables are the same. So you can say this the independent variable here is the concentration of ACl. And how will the amount of sulfur formed in experiment 1 compared to that one in experiment 2? Remember, what is affecting experiment 1 and 2 is the concentration. So the examiner is just saying to you, how will the increase in concentration differ? We know that experiment 1 is having a higher concentration, and we know that the higher the concentration, the more number of particles per unit volume. So we'll expect the amount of sulfur that will be formed here to be higher than that one of experiment 2, because as I was explaining to say what will happen in terms of the collision theory as you increase the concentration. So what I started with is the explanation why the sulfur in experiment 1 is higher than the sulfur in experiment 2. There will be more particles per unit volume of that reacting substance. And then this one, it is just giving us this curve. Already when you see this curve, you can see that this is the curve of what? Of temperature. And you can see that this one represents what? Higher temperature, because of the shape of the graph, which experiment 1 or 3 is represented by T2. So when you go to experiment 1 and 3, experiment 3 is 40 degrees Celsius, experiment 1 is 25 degrees Celsius. So this one it indicates a higher temperature. So definitely we expect that this T2 will be represented by experiment 3. Explain your answer by referring to the collision theory. 3 marks. Number 1, you know how does temperature affect the rate of reaction? It increases the number of average particles, and then it will also, there will be more particles, average kinetic energy of particles, and the second bullet, there will be more particles with energy that is greater than or equals to activation energy, and therefore there will be more effective collision per unit time. So this one was just saying reduce the catalyst, the activation energy of this graph, and show how does a catalyst affect the rate of reaction. We know that the activation energy of this graph will be lower than the first one because a catalyst provides an alternative pathway of activation energy. When you look at chemical equilibrium, the first thing that we understand is that the reaction in reaction 5, they go to completion because they are not reversible, and also they are not in a closed system, so it means they won't go back to the reactants. It means the products as they're going to be formed will not go back to the reactants. However, when the reaction reaches equilibrium, that's when now we're going to have two conditions whereby the reaction must be reversible and also the reaction must occur in a closed system. And we are also going to remember that we are going to talk about Le Chatelier's principle, because as the system is going to reach equilibrium, if any disturbance is made at equilibrium, it means now the system will counteract the disturbance by favoring the side that will oppose that disturbance. So Le Chatelier's principle is based on the system at equilibrium, is based on what will happen if you reach equilibrium and one of the conditions are changed. So that is what is expected again in question number 6. And also this is the question where we normally calculate our Kc, which is our chemical equilibrium, using our expressions, of course, because that is what we need to remember, our expression. How do we represent chemical equilibrium expression, which we are going to get the answer with no units, and also it needs us to apply some of the stoichiometric knowledge in order to calculate, and also know what is the meaning of Kc value. We know that if the Kc value is greater than 1, it means the fourth reaction is favored. It means there are more products than the reactants. However, if the Kc value is less than 1, it means there are more reactants, meaning that the reverse reaction is favored because there will be more reactants than product. That one is normally explained nicely when we are using the Le Chatelier's principle, and we are also referring to which reaction will be favored by the change of any of the conditions. So this is all that chemical equilibrium is all about. It's all about the change in concentration or temperature or pressure, because these are the only factors that will affect our chemical equilibrium. And we need to know what will happen if we change any of these factors, which is going to be explained nicely using Le Chatelier's principle. So the first question is talking about homogeneous reaction. I'm not going to go to the options, but I'm going to remind you what we mean by homogeneous. Remember, when we talk about homogeneous equilibrium, we talk about where the system is having all the reactants and the products are having the same phase. If they are gases, they are all gases, but heterogeneous is when they are having different phases. So you can see that this one is homogeneous, but when you look at all the other ones that are provided here, they have different phases, which represent heterogeneous equilibrium. Also here, remember we spoke about the value of Kc. The greater the value of Kc, so you can see that in both reactions the Kc value is less than 1, but here I think they were referring to the change in temperature. What will happen to the change in temperature? The only thing that I want to talk about in terms of Le Chatelier's principle, let me just go forward. I want to refer to the changes that will occur at equilibrium. You know, when you change temperature, it's either you will increase or decrease temperature. Now, what you need to remember is that the increase in temperature will favor the endothermic reaction. The decrease in temperature will favor the exothermic reaction. Now, the first thing that you need to check your forward reaction, whether it's endothermic or exothermic. The examiner will give you the condition of the change in temperature. Then that change is the one that will guide you to say what will happen if I increase or I decrease the temperature. Then that's when now you're going to start by explaining. So it means you must start by referring what do you know in terms of the change that is provided at equilibrium. Also, when coming to the volume or the pressure, we know that the pressure, when the increase in pressure will favor the side with fewer number of moles, and the decrease in pressure will favor the side with larger number of moles. So when you increase or you decrease pressure, you need to firstly state what you know by the increase or the decrease in pressure. When the two sides are having the same number of moles, it means that system will not be affected by pressure. And also remember that pressure doesn't affect solids, it only affects gases. So those are the changes that you need to remember as you are going to. And then when you increase the concentration of one of the reactants, obviously the forward reaction will be favored. When you increase the concentration of one of the products, you are also favoring the reverse reaction. So just go back and look at how does each disturbance do in the equilibrium as you are going to look at these calculations. Carbon dioxide reacts with carbon dioxide and reacts with carbon in a closed system to produce carbon monoxide, like this reaction. And you can see we are given delta H is greater than 0. It means the forward reaction is endothermic. What does the double arrow indicate? We know that these are the reversible arrows. They are not reverse, they are reversible, meaning they represent forward and backward reaction, because you know that chemical equilibrium is the rate at which the forward and the reverse reaction are equal. And at equilibrium, we also expect the concentration of the reactants and the product to remain constant. So they are saying here, is the above reaction exothermic or endothermic? Give a reason for your answer. So as I've already indicated that delta H is greater than 0, therefore it means this is our endothermic reaction. Energy is being added. Then here we are having a calculation. We are having initially a known amount of carbon dioxide is exposed in hot carbon at 800 degrees Celsius in a sealed 2 cubic decimeter container. The equilibrium constant Kc for the reaction at this temperature is given. So not always that you're going to be expected to calculate Kc. Sometimes the Kc can be given to you and you need to calculate other variables. At equilibrium, it is found that 168 grams of carbon monoxide is present. How is the equilibrium concentration of the product compared to that one of the reactants. And then this says choose from larger than. So you know that when there is something that has to do with concentration, you just need to know whether you are increasing the concentration or you are decreasing the concentration, and give a reason for your answer. No calculation is needed. So this one is about what I was explaining. The one that I want us to look at is calculate the initial number of moles of carbon dioxide. So already we are given a equilibrium, and we know the volume of the container, and we also know the amount of carbon monoxide at equilibrium. So we can start by using the amount of, let me just go straight to we can use the amount of carbon monoxide at equilibrium, which is going to be our 6 moles, to find the number of moles of carbon dioxide that will be at equilibrium. The first question you will ask yourself, why is carbon not included? Remember, carbon is a solid. So when we calculate Kc, carbon as a solid, they are having the concentration of 1, so they are not going to be included, or they will be included, but their value is 1, because when you divide by them, definitely you have to include them. So that is why you can see that when we calculate our Kc, carbon is not there. So we are going to find we are going to use the mole ratio to find the number of moles of carbon dioxide that will react. Remember, we are looking for the initial, but we know the one at equilibrium. So it means the initial will be initial subtract the one, the change, the one that is used, which is the change, and then we are going to also here to divide by 2, which is our volume that we are provided, so that we can find the concentration at equilibrium. Remember, our x is because we are looking for the initial number of moles. So when we write our equilibrium expression, Kc is equal to the concentration of carbon monoxide, which is our product, squared because of the coefficient, and then divide by the concentration of carbon dioxide. So for this is 1 mark. So by writing the correct Kc expression, you get 1 mark. And then here, the second mark is for the substitution from the equilibrium concentration, the 14 of the Kc, because we are provided. And then after that, when you manipulate, you are going to get your answer as 4.29 moles, which are the initial number of moles of this. If you can substitute our S, definitely you'll find it that is correct, that the initial number of moles were. And then let me just go to this one just quickly, because it's about Le Chatelier's principle. They say here, state how each of the following will affect the yield of carbon monoxide, which is our product. So they're just saying which one will favor the forward reaction, because the forward reaction is the reaction that is giving us on the right hand side. So more carbon is added at constant temperature. Remember, carbon is a solid, so even if you add more carbon, you are not changing the concentration of carbon. So obviously our equilibrium will remain the same. There won't be any change. No side will be favored, because carbon is a solid, and adding a solid doesn't change a concentration. But here they say the pressure is increased. Remember that the increase in pressure favors the side with the fewer number of moles. So you can see here we have 1, here we have 2. Remember, we don't include this solid because it's not affecting our pressure of the reaction, because it's a solid. So if it is 1 and 2, it means here our reaction will do what? Will decrease, because we are favoring what? The reverse reaction. So there will be more carbon dioxide that is formed than carbon monoxide. And then we increase the temperature. As we agree that this is endothermic reaction, the increase in temperature favors the endothermic reaction, and our forward reaction is endothermic. Therefore, it means the reaction here, what will happen? It means it will increase, because our equilibrium will increase, because the increase in temperature will favor what? Will favor the yield, or the more yield of carbon monoxide. So I wanted just to say, let's go to the Le Chatelier's principle and see how do we answer questions on Le Chatelier's principle, and also in terms of the calculation. The next topic, okay, we are not going to look at this. The next topic is under acids and bases. Let me just go back a little. Under acids and bases, we know that we are dealing with 2 principles, that is Arrhenius and loripronate. Which is the first thing that you are going to do? You are going to define the two principles, and we know that every acid-base reaction that you are going to deal with on this topic, it will be based on the two principles. And then we are also going to identify our acids and bases as strong and weak, as concentrated or diluted, as monoprotic acids or diprotic acids, and also we have to identify our acid-base conjugate pairs, which is what we need to know before we can think about or worry about these stoichiometric calculations that are normally found in 7,2. And we also need to calculate our pH. The formula of pH is provided on our data sheet as pH is equal to minus log the concentration of H3O plus. And we know that where we want the concentration of hydroxide ions, we can use ionization of water, which is Kw is equal to concentration of H2O plus multiplied by the concentration of OH minus, especially when we are looking for OH. So all of these formulas are there on the data sheet, and we know that they must be copied correctly. Here we are just looking at the strong acids. Remember, the strong acids are there on your exam guideline, and they are provided as examples. Whenever an example on the exam guideline is not there, it means an examiner will give you a Ka value or the pH or the rate of reaction of that acid or base. So Ka value and pH, if the Ka value is greater than 1, we know that it represents strong acid. If it is less than 1, it represents a weak acid. For the bases, it's Kb, exactly as the acid. If Kb is greater than 1, it's a strong base. If the pH is lower, maybe between 0 and 3, we know also that we represent a strong acid. And then if it is greater, like 10 to 14, we know that we represent what? A strong base. So all those identification facts about acids and bases, we just have to look back on them and see whether we can find strong acids and strong bases. And in this case, the only strong acids that we know is hydrochloric acid, because all the carboxylic acids are weak acids. So I just want you to remember this one is about Lorentz principle. You can go back and look at the definition, and you can be able to find the correct answer. This one is about the dilution and the pH. So whenever you are provided with 0, something mole per decimeter cube, it is already telling you that that acid is diluted, but you don't know how much diluted is the acid or base. So how do I know that 0, is talking about dilute acid or base? It's because when we calculate concentration, C is equal to N over V. And if our denominator is greater than the numerator, the answer will be 0, showing that there will be more of a solvent than a solute. But if our answer is like a solid, like starting from 1 going upward, it is already indicating that that acid or base is concentrated, because there will be more of a solute than a solvent. So just look at the numbers and check whether how diluted an acid or a base is, because we can sometimes need to compare like 0,1 and 0,01. So this one is less diluted than this one, or this one is more diluted. So in terms of the concentration, this one will have a higher concentration. So the higher the value, the higher the concentration. I know we are now at 30 or 25 to 3, but I just want us to at least look at one of, okay, yeah, it is. Sorry about that. Okay, this question, even though it's a multiple choice question, but it is everything to do with pH. You are given carbonic acid and you are given the pH of carbonic acid. So in terms of acids and bases, whenever you need to calculate pH, you will only calculate the pH of strong acids and strong bases because they ionize completely. But when you are given a weak acid like carbonic acid, the pH will be provided. So they're saying, what will be the pH of the hydroxide ions? Remember, the hydroxide ions are the OH minus ions, and you cannot use the pH calculation to find the hydroxide ions. So it means you firstly have to find the hydronium ions, and then Okay, plus here. And then after that, and normally I say we can just change this and say the concentration of H3O plus is equals to 10 minus pH, so that at least if you have a problem of calculation, you might be able to find the pH quickly, and then it's going to be 10 to exponent 3,4. After getting the concentration of H2O plus, that is when you're going to use the KW, the one that I gave you, the one that I just said, you A minus multiplied by H2O plus, to find the concentration. Remember, this is the constant, and this one we don't know, but this one we will know as our X, and then we will divide by the X, which is our concentration that we find here, and we can be able to find the concentration of OH minus. I wanted to, let me just say why. I wanted just to show you how do you move from a concentration to of H2O plus to a concentration of OH minus. This one is about acid-base conjugate pairs. We know the difference between an acid and its conjugate base is -1. And here we are actually given the condition of our acid, and we are told that it's greater than 1. So whatever the acid is here, we will already know that it's a strong acid. The equation below shows the reaction that occurring between hydrochloric acid, HCl, and ethanoic acid solution. Both acids have the concentration of 1 mole, because definitely we want to obtain the issue of the Fair test. Reaction 1, we have provided the dissociation of the ionization of hydrochloric acid in water, and the Ka value is provided as 1,3 times 10 to the exponent positive 6. But for the ethanoic acid, the Ka value is 1,8 times 10 to the exponent -5. So already the Ka value here is less than 1. So it already tells us that ethanoic acid is a weak acid. So the first question says define an acid according to Lorentz-Bronsted theory and identify one conjugate acid base pair for reaction 1. So this is our reaction 1. Is either is water and the hydrogen ion, or is hydrochloric acid and the Cl minus. Any of the two can be the pair of conjugate acid base pair. And then which solution 1 or 2 will have the lower pH value? We remember that lower pH value indicates strong acid. So we'll expect reaction 1 to be a strong acid to have a lower pH value. And the reason is because the Ka value, number 1, is greater than 1. And number 2 is because it ionizes completely. That is the second reason why this is a strong acid. So the first mark was for 1, and the Ka value was the second mark, and the definition of a strong acid was provided as our third mark, because in chemistry our definitions are becoming our explanation. This one is the question normally 7.2. We are provided 10 cubic centimeter of 1 mole per decimeter cube of sodium hydroxide solution, and this is diluted in water until the pH is 13. They say calculate the number of moles of sodium hydroxide that are initial of the initial solution. So we are given the volume here, we are given the concentration here. However, your volume is in cubic centimeter. We are going to divide it by 1,000 for us to get cubic decimeter. Then we know that C is equal to N over V, and then we are going to substitute our volume, our concentration, which is 1, and we are looking for number of moles. I think our volume will be 0,01, and when we multiply, our number of moles is going to be 0,01 moles for the first one. That is why it's 3 marks. And then calculate the volume of the diluted solution. Remember, now we are looking for the volume of the diluted solution. We know that the pH of this solution is 13. Then sodium hydroxide is a strong base. It dissociates completely. It means if you can find the concentration of OH minus, it will be the same as the concentration of OH of NaOH. But how do we find now the concentration of OH minus? Remember, the pH value was provided to us, so we can use the pH, which is minus log the concentration of H3O plus, in order for us to find what? To find the, let me just go to find the concentration of H3O plus. Then after finding the concentration of H3O plus, we can find the concentration of OH minus using our Kw. When we get the concentration of OH minus is the same as the concentration of sodium hydroxide. The relationship is because sodium hydroxide dissociates completely. Then we are going to use our formula, or we can use our dilution formula to find the volume of the solution that will give us 18 as our pH. The last two topics of our chemistry will be our galvanic and our electrolytic cell. First of all, we need to know what is the difference between the two cells in terms of being exothermic or endothermic, in terms of being spontaneous and non-spontaneous. And we also need to know the definitions of oxidation and reduction. We are going to use this in terms of electron transfer and in terms of oxidation numbers. And then we will use our table of reduction potential most of the time to write our half reactions and also to write our net reactions and our cell notation. So remember all those factors of how did we, because this was the last topic of the year. I think most of the facts we still remember. And we are also going to calculate our EMF only for a galvanic cell, because we calculate the EMF of all the spontaneous reaction, whereby we are going to get a positive value that indicates spontaneity of the reaction. We are going to use the formulas that are provided to us. So that is why we are saying copy the formulas correctly for you to be able to calculate the EMF. So in terms of the galvanic cell, we will talk about the movement of electrons, we'll talk about the movement of ions, and knowing that there are two types of circuits, which is internal and external circuit, whereby internal circuit is made of two electrolytes and a salt bridge, and we expect our anions and our cations to move there. And the external circuits will be made of our two electrodes and our wire. And then we know that the electrons will move at the wire, where we are saying they will move at the external circuit. So those are the things that I want us to remember in terms of the oxidation and reduction. So remember, if you are given a reaction, you need to be able to identify your oxidizing and your reducing agents, those agents that donate and that agent that accept the electrons. So we said we will always identify the reducing and the oxidizing agent on our right hand side of the reaction, because they will assist us to check which one will be which one will have the reduction in terms of oxidation number and which one will have the increase in oxidation number. Like in this reaction here, you go straight to your reduction potential table, you check which one cannot be a reducing agent, which one cannot be able to lose electrons. And if you look at all this, you will find them in your reduction potential table, because that is the one that will indicate all your reducing agent on the right hand side and all your oxidizing agent will be on the left hand side. So it just says which one of these are on the right hand side and which one are on the left hand side of the reaction. Okay, this one is about the definition. This one is a reaction, as I said, in a reaction like this one, the oxidation number here is 0 and it goes to 2. So if there's an increase in oxidation number, you already know that this is a reducing agent, and this one is oxidation number from 1 to 0. It means it's our oxidizing agent because it's being reduced. So in the following, copper is there. Definitely it cannot be an oxidizing agent. It must be a reducing agent. But remember, a reducing agent is not being oxidized, it's not being reduced. A reducing agent is being oxidized. So that is why D is the correct answer. We cannot expect that the examiner will always give us a galvanic cell as a cell, being drawn. Sometimes you can be given a reaction, sometimes you can be given a cell notation. So remember, how do you identify your electrodes, and also how do you identify your salt bridge in a cell notation, and how do you also read your cell notation. Then this one is just an example of a galvanic cell and how to calculate EMF. As you can see here, you are provided half cell A and half cell B. Half cell B is a half cell of water and half cell A is a half cell of copper. So they are saying I define oxidation in terms of electron transfer, and initially the concentration of H plus ion solution at B. So remember, this operate under standard conditions. So already the concentration we know is 1 mole per decimeter cube of all the electrolytes. So if they say they want the initial concentration of H plus, here you already know that is your standard concentration, which is 1 mole per decimeter cube. And name a metal which is used at half cell B. Half cell B, because it doesn't have a metal, we know that we are going to use platinum in our galvanic cell to provide an electrode for that half cell if the electrode is not there. And then formula of a reducing agent, because these two half cells will react with each other, you will see that copper will be our reducing agent as you combine the two. And the reduction of reaction, we will take this reaction from the reduction potential table and write it as reduction, and the balanced overall reaction where we combine the two reactions, making sure that the electrons are balancing in both the reactions. This one is showing the EMF and is showing the decrease in the EMF. Yes, in a galvanic cell, as the cell operates, the EMF of the cell will decrease. And the reason why the EMF of the cell decreases is because of the increase in the reactants, in the product ions, and the decrease in the reactant ions, until the EMF is 0, where we say the cell has reached what? Equilibrium. So here, when the EMF indicates 0, it means our cell has reached equilibrium. And then this is our initial EMF that we normally calculate by using the formula E theta cell is equals to E theta cathode subtract E theta anode. So this is normally what we use. So here they say explain the decrease in EMF. Already I've explained that is because of the decrease in the product ion, in the reactant ions, and the increase in the product ion. And then they say what happened at time T1. At time T1, that's where our cell has reached equilibrium. So this reaction is just the indication of what will happen to the EMF. Okay, we are having a table shows the reaction A and B used to assemble the electrochemical cell under standard conditions. So we have half cell A, which is copper 2 plus 2 copper, half cell B, which is silver plus 2 silver. So we normally, when you have reactions like this, the first thing you just ask yourself, which one will undergo oxidation, which one will undergo reduction, and you can find that by using your reduction potential table. Now you need to state energy conversion that takes place in the cell. Of course, because there are two electrolytes, it shows that this is the galvanic cell, and the energy conversion is from chemical energy to electrical energy. The interesting question is that calculate the mass of silver nitrate used to prepare 150 cubic centimeters. So when they are looking for a mass, we know the formula to calculate mass is equals to N is equals to M, small m over big M, mass over molar mass. So it means the first thing that we need to find here, we need to find at least the number of moles so that we can calculate the mass. But now what are we given? We are given only the volume. The next thing that the examiner gave us is the condition of the cell, standard condition. And we know that if we are given standard condition already, we are given what? The concentration of the electrolyte. So we can use C is equals to N over V to find the number of moles, where concentration is 1 multiplied by, it's going to be 150 divided by 1,000, which is going to give us 0.15. So we're going to say it's, this is going to be 1 is equals to N over 0.15. So we'll find our number of moles as 0.15. Then after that, we'll go to our formula. We say N is equals to the mass, we don't know, but the molar mass of silver nitrate, which is AgNO3. We will just find it. Ag, I think, is 80 plus 14 plus 48. We will find the molar mass, and then we take the molar mass, we substitute here, and we find our mass in grams. So that is why I was giving you this question, because sometimes we think there won't be any calculations on electrochemical cells, and they will be. So you'll get your answer as this one, and then define a reducing agent. So most of the things that are happening in a galvanic cell, they are also happening in an electrolytic cell. How will the EMF of a cell be affected if the concentration of copper ions is increased? Remember, because copper is our reducing agent, so its ions are going to be product ions. So if the product ions increases, we expect the EMF to decrease. The last one is about electrolytic cell, which is going to be just few minutes. We are having decomposition of copper chloride as one of the process, electrolysis of concentrated sodium chloride, electroplating, and refining of copper. Please go through all these processes and see whether you remember the products that are formed and the conditions of each and every process, because this is an endothermic type of reaction and is non-spontaneous, whereby we are going to see electrical energy being converted to chemical energy. So these are the half reactions that you find under each process. For the decomposition of copper chloride, the oxidation reaction will be copper 2 chloride, chloride ions forming chlorine gas plus electron. In terms of reduction, is copper 2 plus electron forming copper. So you can even know the oxidation and the reduction of each reaction. Here is about the refining of copper, where copper, which is impure, forming copper ions, and those copper ions that are formed forming what? Forming pure copper. So the copper that will form here is pure, and it will be found at the cathode. The impure copper will be found at the anode side. Then when you go to electroplating, remember, is the coating of a metal with another metal, whereby we use an electrolyte that is having the same ions of what you want to coat with. So if this is metal X and it undergoes oxidation, the ions of metal X will undergo reduction and coat whatever that you want to coat at the cathode side. So whatever that you want to coat, let me just write, whatever that you want to coat, you will put it at the cathode side, because remember, you are now using a cell in order for you to allow the movement of electrons. So obviously at the negative terminal, that's where you are going to find your cathode. At the positive terminal, that's where you are going to find your anode. And the last one is the concentrated sodium chloride electrolysis. So I want you to know the half reaction of the oxidation and also the half reaction of the reduction, which involves water. So these are just the summary of all the reactions that are needed in order for you to understand electrolysis. So in an electrolytic cell, the battery is used as, remember, a battery is used as a power source. It's not an agent, because a battery doesn't react, and it's also not a salt bridge, because in an electrolytic cell we don't have a salt bridge. And then here you are given the conditions of electrolysis. I think this one is about the purification of copper, or purification, yeah, it was purification of silver. So you need to know what are the conditions of purifying and what will happen to the electrolyte as you are undergoing the process of purification. Because what you must know is that during the process of purification, the electrolyte concentration will not change. Also during electroplating, the concentration of electrolyte will not change. The reason is being that the rate of what reaction and the rate of reverse reaction of the two processes that I just explained is the same. So that is why you will find that the concentration will not change. However, when you are doing the decomposition reaction, you will definitely expect the concentration to decrease, because you will be using ions inside the reaction or inside the electrolyte to undergo a reaction and becoming reactant ions. So on the concentration, the decomposition, the concentration of the electrolyte will decrease. This is an example of the purification of copper. We know our anode will always decrease where the anode is an active electrode, and our cathode will increase because most of our atoms are formed at the site of the cathode. And this one is the electroplating. We know that if you want to electroplate this bracelet with chromium, we need to have the chromium ions, and we also need to have the chromium as a metal so that it undergoes oxidation and it forms the chromium ions. Left with only 2 minutes that I place for myself. When you are given have reactions like this, because this was a very confusing type of equation, you are having copper and copper, carbon and copper. Remember, carbon is our inactive electrode. So when you see carbon, you must not expect it to undergo any form of reaction. You must expect it to act as an electrolyte and just conduct electricity. And this is just an example whereby we are doing the electrolysis of concentrated sodium chloride, and I also gave you the half reactions of that concentration. This one is about electroplating. We are electroplating a copper coin with nickel. You know that you need nickel and the nickel electrolyte. Thank you so much, learners. I know we have exceeded our time, but at least I wanted us to touch all the topic, because on Monday you will be writing on all the topic. All the best from all of us as you are going to write your final paper on Monday, and we wish to see you next year at the tertiary university. Thank you so much, and goodbye from me.